Algebros. I am on page M212. If you want to follow along in your book, I would recommend you doing that so you can write stuff down as we go over it. So we're going to continue to talk about factors and zeros and relating them and practicing our factoring skills and using different methods to factor different problems. So Tony and Ava each attempt to factor f of x equals x cubed minus 2x squared plus 2x. Let's take a look at their work. Tony says that he first removed the GCF of x, which is a great move. It's perfect. It's what you should do if all of your terms share a common factor. So when he takes that x out, he's left with the expression x squared minus 2x plus 2, which cannot be factored. And so he says his final answer in factored form would be f of x equals x times the quantity of x squared minus 2x plus 2. Okay. Ava does the same thing to start. She takes that x out. Perfect. And then with the trinomial that she's left with, she notices that she can't factor it just like Tony did, so she uses a quadratic formula. If you remember when we first introduced the quadratic formula, I said that the quadratic formula was super important and super helpful because you can factor any and every trinomial using the quadratic formula. So you can't always solve something by factoring. Completing the square is kind of iffy, and then you can't always solve using square roots. But the quadratic formula is foolproof when it comes to trinomials. So it looks like she substituted everything in correctly. So remember that the A value would be 1, the B value would be -2, and our C value would be 2. So if you look at all of her numbers she added those in correctly. Then we simplify. You can follow her steps. She would get a +4 minus 8, which would be -4 underneath the square root. And I know we kind of glazed over the square root of a negative number last semester, but remember the square root of a negative number would be that I, that imaginary number, and we can follow her steps of simplification. The 2 goes into that both times, leaving us with 1 plus or minus I, which is correct. She has used the quadratic formula correctly and beautifully and says that in factored form, this problem would be x times the quantity of x minus 1 plus I times the quantity of x minus 1 minus I. So she separated the plus and the minus out. There's the plus, there's the minus. Awesome. So who's correct? Well, they both are correct in their own right. It depends on what you are considering for your answer. So if you are considering the set of real numbers, Tony is correct, because he has this factored as far as you can while maintaining all real numbers in his answer. And Ava is correct if you are considering the complex number system. So Ava is correct. So the complex number system involves those imaginary numbers. So they both are correct. You can use the distributive property to rewrite Ava's function. We're not going to go through all of those steps. But we are going to identify the function, or the zeros of the function. So remember, if we're going from factored form to find the zeros of it, we set each factor individually equal to 0. So we have x equals 0, x minus 1 plus I equals 0, and x minus 1 minus I equals 0. And we solve for the x value. So the first one is already solved. 0 is one of the zeros. To get x by itself over here, we're going to add 1 and subtract I. And we get x equals 1 minus I. That's our second 0. And then over here, we're going to add 1 and add I. And x equals 1 plus I. And that is our third 0. So graphically, let's see what happens. So I'm going to pull up the Desmos graphing calculator. I'm going to type it in before I drag it over so I can see exactly what I'm typing in first. And we are typing in x cubed minus 2x squared plus 2x. So this is our graph. So we can see a turning point is happening here. So we're kind of going and going. And the only time it crosses the x-axis is at 0. And if you remember, if you look back, the only real number that was a 0 was 0 itself. So when you have imaginary solutions, that means that this does not cross the x-axis at those solutions. They're imaginary solutions. They don't cross at that point. But these are what they would represent, this turning point. Okay? All right, so now that we have seen an example where we do have complex roots, we're going to do some more practice with those, because up until this point, I've made sure that you haven't had any complex roots. But now that we've seen it, you guys can handle it. So stay tuned for the next video when we are going to fill out this chart. I'm going to help you fill out a few, and then you're going to be asked to fill out the rest of it for your assignment today. So go ahead and head over to the next video, and happy mathing as always.